Hello, my name is Jonathan Omara. Today we shall look at some of the tools we can use, we as data scientists. Okay, so we shall see how we can install these tools and set them up on our local computers. We shall also look at some of the tools we could access online freely. Most of the time, maybe because of better computing power than our local setup. And then we shall have some brief introduction of some of the packages we need in data science. Basically, we shall look at Numpy and then pandas. We shall interact with it. So just to keep the video a bit short, we shall not go so much into detail. So to start with, let's look into our first tool that we need as data scientists. One thing that I love most is what they call Anaconda. Now, when you install it, it's usually written known as Anaconda Navigator. So if you want to access this tool, you just go to www.anaconda.com/products/individual. So for those ones who are on Windows, like me, automatically it will bring for you a download button that has the Windows sign. If you're on, maybe you have Mac, you just select here, maybe Linux, you just select here, and then you get the package that is right for you on your PC. Here's some documentation. If you want to take some time and go through, it's okay. You can also check it out. So when you download it and install it, usually when the installation is successful, you should be able to see something that is similar to this. So one thing I like about this Anaconda Navigator, it is so organized. Okay, it's almost like a package for everything is just here. So the other good thing with it, it always comes with a Jupyter notebook already, as a part of it, already installed with it by default. There's also a Jupyter Lab. It's almost similar to this Jupyter notebook, only that Jupyter Lab has more of administrative powers. You can do a lot on the notebooks, you can do a lot on the cells and so on and so on. So you could also try to check that out. But for this case, we shall only look at the Jupyter notebook for today. Maybe on some other day, we could check out the Jupyter Lab. But really, there's nothing so much different from the Jupyter notebook. Then there's also Spider. People use it a lot out there too, but I've seen not so much. You could also try installing PyCharm. Now the professional version is it's a paid version. So if you don't have that money, you could just Google out and install PyCharm community. Now the moment you install it automatically, this Anaconda Navigator will detect it and it will display it on its dashboard here. Another tool that is almost similar to our Jupyter notebook. This one, basically, people use it for scientific computations. Okay, there is the R Studio. You could just come here, click on install, or the other thing you could just Google it out, www.rstudio.com/products/rstudio/downloads, and then you come and get a free version, the R Studio desktop. Just click here and download it and install it. Then you start using it also like that. The other thing now, you don't need to set up the notebook and Jupyter notebook and so on and so on. Like I've seen other people, they install this as a standalone thing. But now this Anaconda Navigator comes in with the things, and it is just in one place. You don't need to do any kind of configurations. So when we launch our Jupyter notebook by clicking this button. It should open for you something that is like this. Usually your file directories. Okay, so since today we are basically going to look at some introduction of the pandas and the Numpy. We have seen some of the tools that we could use. Okay, maybe one other thing that I had left out, we have the Colab. Now, this one is provided by Google. Basically, people like using it because, you know, it provides enough computing power. Okay, it gives you a free GPU that we mostly don't have on our PCs, so you can run heavier models on it than when you're on your local computer. So if you feel like you want to access this, it is free. You don't need to pay anything, but you need to have internet for you to use it. So usually it has documentation that you could follow and try to see how you can get set. Okay, maybe you could just go straight to working with data, and then you check one of these, how to load data. So loading data, data sheets, Google Cloud Storage, and so on and so on. So you can see here they're taking you through how you can load data from your Google Drive. Okay, could maybe be working with data from your Google Drive. I see something like Pi Drive. I've never used that before. Could also be downloading files on your local computer. You could also be uploading file from your local computer. No, it's just right here. Just get time and go through it. It's good to know some of the things. So coming back to our interface here that we launched from Anaconda Navigator. So usually it opens for you your file directories, where in most of the times it launches from where you directed your notebook to be launching from. So you could also find time and see how you could configure it to be launching from a directory, like maybe a partition, a storage partition of your own desire. So I made mine launch from a partition that I love most, where I have more storage than it always launching from my C. So you could also try that out. A lot of things is always there on Google. Just get time and type, do some bit of research on it. So this is basically like a server that is running. We can start up our Jupyter notebook. Jupyter notebook is basically like a platform that allows you to write code. Okay, so here we are going to work with Python. So if you want to add a Jupyter notebook, just come to new. Okay, then click on Python 3, and let's give it some time. Well, it also depends on how fast your computer is, but it shouldn't take this long, but it's going to load. Okay, it's just almost done. All right, there we go. So it always has to first start your kernel before you can start doing anything with it. So let's give it some time. All right, so maybe as it connects, okay, it is now connecting. So we have these cells, okay. So this is where we always type our code. It is where we always write our text, depending on the type that you set your cell to be. Okay, so these cells we could just just keep on adding them like this. There are shortcuts on the keyboard you could try out, like escape and then Control B. For example, you're here, you just press escape. and then B, just press B. Sorry, it's not Control B, just press B. Then if you want to add like above it, press escape and then A, and then A, something like that. Below is escape, then B, 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 like that. That is how we add the cells. So one of the most common formats of the cells that I always like using, basically there are two. The code, if I want to write my code in Python, okay, just need to select it to be of that type. And then there are scenarios where I want to make some text. So I change the cell format to a markdown format. So coming to our agenda of today, what we are going to be looking at today, looked at some of the tools, okay, and where we can access them for installation and setting them on our local computer. We shall look at some brief introduction on maybe Python. Basically, we're going to be using Python. Never used R, but you could also try it out. We shall look at a brief on Numpy, some of the packages that really come in so handy when you're doing data science. And the other one is pandas. Then we shall do a bit of data wrangling. Wrangling is just some term that basically means playing around with something like data. So we shall just find, we shall try to manipulate data in some way that it can produce something that we want. So to run the cell, just come to run here, and then it has already, like made it in form of text, something like that. That is how you run the cell. Just come and then click on run. Otherwise, you could just press Control Enter and then it executes it. But because there's nothing here, it is not executing anything important. So to start with, let's look at some intro to Python. Now, Python is really a very great language and it's very easy to learn. This is a language that people are widely using out there for data science, doing training machine learning models, and doing data analysis and so on and so on. Of course, there are other languages like R. It just depends on what you want and how you can access it. So someone who has used Python for so long, and we shall be discussing Python basically in this video. So I won't really go so much deep into Python, but maybe just show you some of the capabilities and what are some of the things you really need to know, in Python before you can push on with data science and so on and so on. So Python, just like any other language, it also has, print statements. Okay, we have seen whenever you're learning in a new language, you could the first program people always do is print hello world. Okay, so how do we do this in Python? It's just a matter of writing print, open double or single quotes, and then type in our word, hello world. So when we run this, see, it does print it there just like that. So Python also has some functionalities like doing arithmetic calculations. It can work as a calculator. What do I mean by arithmetic calculations? It could do a print statement of any division. Okay. Okay. Something like that. We could also do a multiplication. See, we'll also do, squaring functionality. Okay, not like, but raised to some power, where we could just use this. Okay, oh, sorry, I wasn't changing here. My bad. All right. 5 to the power 6. Okay, this is not right. Okay, something like that. Okay. So that is one of the functionalities of Python, it can do all that. You could also do some statistical calculations, like maybe get mean. Okay. So like, what is the minimum value given a set of these values? Could also get max. Then what's the maximum value from this set of numbers, and so on and so on. Okay. So what are some of the things you really need to concentrate on in Python? Okay. You need to look at how to write functions in Python. So how do we write a function in Python? So we start with def. For example, if you want to write a function that gets a difference, okay, between numbers. Okay, maybe we have A and B. And return for us the absolute difference between A and B. What does this mean? If I say absolute, absolute is more like if A is greater than B, it shouldn't return for us. Okay, if A is less than B, yes, that's what I wanted to mean. Maybe like if we have A, so an hash like this is usually a comment, okay? For it, even though you execute that cell, it is not, that code is not going to be executed. It's more like you're commenting out that code. Maybe it's more like you're writing a statement, not something that should be executed. So for example, if A is less than, not less than B, our answer is going to be negative value. So what ABS means, absolute, something like that. What it does is that it won't return for us a negative answer. It should return for us a positive answer in all situations, whether it is less or greater. Okay. So when we call this function, for example, we have 5 and 6. When we execute this, okay, I think we have a name error B. Oh, sorry, I used B. Something like that. Okay. So you can look at other ways of how you can write functions in Python. Okay. Another thing you could also concentrate at is the booleans. How does this look like? Okay. Booleans are just, okay, it's between two values. It's either 0 or 1, a true or false. Okay. For example, is maybe 4 equals, is 3 equals to 4. So in Python, if you're doing an equality sign, you use double. When you just use a single one like this, you're going to get a syntax error. So if you want to query with an equal, like an equal relationship, you're trying to query, you're like, is this equal to this? You use double equal sign like this. Okay. One other thing you could also check is 3 greater than 4. It tells you false. So you could look at the booleans, how you could be creative around booleans, because it comes in so handy when you're trying to access data from your data frames. Okay, we shall see what it means by a data frame. Okay, how we can create them, how we can read our data in forms of use our data in form of a data frame and access values from it. Okay, so the other things you can concentrate on are data structures. Data structures basically mean some of the storage structures that we have in Python. Okay, so some of these the ones that matter most in Python, we have this. Okay, we shall look at them. We have dictionaries. Okay, basically those are the main one that you may use most in data science. So you could create time and see how you can manipulate lists and dictionaries. So an example of a list, let's start with a list. What's a list? I have an example of a list of prime numbers 3, 2, 3. What's the next prime number? 5 and then 7. Okay, this is called a list. It's made of square brackets like this. Okay, and then your elements can either be numbers, it can either be text. It doesn't matter whether you use double quotes or single quotes, it's the same thing almost. So how do we access some of these values from these sets? For example, I want to access the first value. Now, usually the first value is given an index of 0, then 1, 2, 3. That is how weird Python is. It starts counting from 0, not from 1. So if we are to access at index 1 of this, we get this. Okay. We have to access at maybe index 3 of our text type. No, we get 7. Okay. Where you could also use negative. Sorry, where you could also use negative values to access them. For example, if I want the last value here, I just use -1, start counting from behind. If I want another one, maybe the second last, then I use -2, something like that. So that's how you can play around with this list. You can use them to store values. You can see how you can replace the values. For example, if I want to replace maybe the second last thing, maybe this 5 in our primes here, to be maybe an 8. Okay, so we are going to say we want our last value, second last value, to be 8. So let's print this list again and see it just changed from 5 to 8. Okay, there's a lot you can do with this, and because we are Not going to look so much into depth for the things. We shall move to our next one, our next data structure, which are dictionaries. So how do these dictionaries look like? How do we create them? We usually use these curly brackets. Okay, so a dictionary is formed in a way that you have a key and then what is its value. So for example, if I have my key as one like this, and then my value is 1. Okay, then I have another key like 2, and then my value is 2. I have another key like 0, my value is 3. Now usually it is not good to have keys as numerical values. Okay, so it is always good to have it as text. So in a similar way, how do we access these values in a dictionary? So for example, if you want to access our 1, now for this one you don't use 0. Okay, for example, let's try 0. You see, you get a key error. So how do we access these values from dictionaries? We use their keys, something like that. So if you want to maybe change this to be some other value, for example, we want it to be 1 1. Okay, see, okay, it's 11. I wanted to say 11, sorry. All right, so we have changed it to 11. See, that is how you can play around with this. Okay, there's another thing you could look into, loops, how you can write loops, conditional statements, if statements, those ones, for loops, how you can do some comprehension. Comprehension comes in handy if you want to summarize. Sometimes you code into just one line that is easily readable, rather than having very many lines. So most of the time, maybe you want to populate something into a list, it comes in so handy. So you could get time and check that out. So we're going to look into our first package, of Python that is mostly used so much into the field of data science, and that is Numpy. So how do we install Numpy? Most of the times when you install Anaconda Navigator, and then it has come in with these packages, Jupyter and then Jupyter Lab, it always comes in with the Numpy package and the pandas package. But just in case you don't have it already installed, you just need to do install Numpy. Or you could just Google out how you could install Numpy from Google and then follow the procedures. It is always good to read, try to check out how some of the things are done. Okay, you don't need to cram this. Internet is always there unless if something happens one day and just disappears, of course, which I know that can't be possible for now. But you just need to use this to install Numpy. So if you want to use Numpy, how do we use it? So in Python, whenever you want to use a package, you always have to first import it. So let's import Numpy. So you always import it as some abbreviation, for easier access. We don't need to keep on writing Numpy every time we want to use it. So it's always a convention in Python programming that Numpy people always import it as NP. Okay, so what do people use Numpy for? Most of the times, Numpy is used for scientific computations. Okay, computing maybe most of the times arrays, vectors, and so on, so on, generating some range of values and so on and so on. Basically, that is how it comes in handy. But I know most of the times you may not use it because in most of the cases you'll be dealing with data collected from somewhere. Most of the times you'll be dealing with data frames, CSV files, Excel files, and so on and so on. So you may not use Numpy a lot, but usually comes in handy if you want to, do some calculations. Maybe you don't want to work with pandas. This is also another package that you could use to substitute pandas and do some calculations. Let's go through some of the examples and see. Okay, so I have arrays. Okay, so one other thing you should take note of is if you are really to do things with data science, you really need to be someone who has mastered some math, some calculations out there. We know that there are some calculations that deal with arrays, that deal with vectors, and so on and so on. So how do we create arrays using NumPy? Okay, we have an array assigned to a variable a. Okay, we have 1, 2, array. Starting from 4, 5, and then 6. So let's say these are our values. Maybe these are our sets of values that we want to work with. Okay. We have to always execute this cell so that we have these variables already in memory. So we can do a subtraction. Okay. See, it gets this minus this, a minus this. Okay, maybe to just illustrate something brief. It is more like dealing with vectors. Okay, so we have a and then b. So we are subtracting. So we have 1, 2, 3, then we have 4, 5, and 6. Then what is it doing? So it gets 1 minus 4, we get -3, gets 2 minus 5, gets -3, it gets 3 minus 6, it gets -3. Basically, that is what it is doing. Okay. Then you could do a multiplication, like you have a times 2. Okay, just gets 1 times 2, 2, 3. I mean 2 times 2, 4, 3 times 2, 6, something like that. There's a lot you can do with NumPy. Okay, you could okay, there's also another thing there with NumPy, how to access these values. Now these are basically like lists. Okay, whatever you can do with this, the other side you can come and do them on arrays. Okay, so you can create an array of very many values. For example, you could have an array that is maybe made up of zeros. Okay, so that's the formula. So you give in, maybe you want 3 rows and then 4 columns. Okay, let's see, the 1, 2, 3 rows and then our 4 columns. Okay, 1, 2, 3, 4, something like that. There's a lot you can do in NumPy, especially scientific computations and so on and so on. So if you really have like this kind of columns and you have a lot of calculations you want to deal with, you can create arrays containing those values, or just maybe reading that data and then convert them to NumPy, and you can easily interact with them. Okay, you could also use NumPy to create some range of values, For example, if you want to create values maybe between 10 and 25, and maybe you want to skip like maybe 5, 5. Okay, that's an error. Oh, sorry. Arrange. Oh, arrange. Yeah, sometimes such things happen. All right. So you see, we have 10, 15, 20. So we started with 10. Now, usually it keeps out this one. Okay. So it keeps it out. If you wanted it to be included, maybe you could select 26, and then it is included there. The other thing, you could generate decimal numbers. Maybe you don't want whole numbers, you just want to generate some decimal numbers. Okay. The other function of Numpy that can do that is it's called linspace. Okay, maybe we want to generate some numbers between decimal numbers between 2 and 0. Okay, and how many numbers do we want? We want around 5 of them. Okay, so it starts from this and then it ends on this. Okay, so we have 2.0, 2.25, 2.5, 2. So it divides, it gets all decimals between this, and then it sees how many can I really bring out, that are equally spaced, and they are only 5. Okay, something like that. So that is to do with, pandas. You could, to do with NumPy. You could try to check out and, look at these other functions that we left out, what they do, and, there's a lot out there. If we are to only look into this, we can even take the entire time just, trying to look at this and NumPy. But let's move forward. So let's go into pandas. Okay, the package that is widely used out there, working with data. Okay, so similar way, if it is not installed in your package when you install the Anaconda Navigator, you can just do a pip install pandas. Okay, one thing maybe I forgot to show you before, when you're running this within this cell here, let's try it out and see. You put that first exclamation mark here, so that it identifies it as a terminal function. Okay, like a command, a CMD command. It's like you're running it the other side of the terminal. Okay, you need to include the exclamation mark. So maybe as it runs, you can be proceeding. So if you want to use this package, import pandas. So convention is as PD. Okay, so it's slowing a bit, but let's just have a look at what it brings. Oh, sorry about these warnings. Yeah, that's when you work with Windows, you get a lot of warnings. So mine, it's already there. It's already satisfied, as you can see. So there's no need. Okay, there's no need of reinstalling it. But that's how you can install it from this side of the Jupyter notebook. Okay, so it has already imported. So in pandas, we basically deal with what they call data frames. Okay, so the tables and rows, the ones that you see in Excel and so on and so on. Now, when we come into pandas, this will call them data frames. Okay, so how do we create these data frames, or how do they look like in pandas? Let's look at creating data frames. So an example data frame, let's maybe have we really don't need to cram some of the things. They're always there whenever you forget maybe where to access them from. You could just Google them out, maybe how I can create a data frame in pandas and so on and so on. Okay. The other thing is if I forget how to use that function, I usually just write the function and then I put a question mark in front of it. Oh, okay, this is will this work like this? All right, so this is not more of an objective function. Okay, more like an inbuilt function, but I'm going to show you what I wanted to to mean here. Let's move ahead. So how do we create our data frames? Okay, so creating our data frame would use a dictionary. We add it, so where our key is going to be the column name. Okay, and then our values are going to be the rows. Okay, so we would have yes, maybe you're trying to record people who are doing some voting, and then maybe the first time you ran the ballots, maybe 50 people said yes. Then the second time you ran, 40 people said yes, something like that. Then you have some people that said no. Okay, maybe like some 20 values, 20, and then some 10 at the end, something like that. So when we run these, yeah, whereas expect that for pandas data frame, yeah, no wonder we're getting the error. There was just some misspelling here. So what I wanted to show you is whenever I forget how to use some function, I always write the function with a question mark. Okay, so it gives you a direction of how to use that function. So you can see that pd.data frame, if I want to print, I give it the data. Okay, so in this case, this is our data. We only gave the data. We didn't bother much on this, which columns and so on and so on. So you would just even just write data equals to that, and it gives you the same table when you run it. Okay, so that is one other way of how you can keep on checking how you can use a function just in case you forget about it. Okay, just write the function and a question mark in front of it. So most of the times we use pandas to deal with data in columns and rows. Okay, but now here we shall talk about dimensions and maybe features, especially when you come to machine learning. Okay, but for the start, let's call them columns and rows. So most of the times you'll be reading data from CSV files. Now CSV files just are comma separated values. They're mainly just separated by commas. Okay, so how do we read such files? How do we read such values? Okay, so reading data into our notebooks. So let's call it, give it a variable df. So we shall say pd. Now, sometimes you may forget maybe the whole function. You just need to press tab. It will complete for you. Try to bring for you suggestions of some of the complete, the complete name of the function. So we open those brackets and then the quotes, to put in the path. So it's always good to start with a dot, and that forward slash. So where your notebook is running, it's always good to put your data also like a folder having your data where your notebook is. So where you saw we put a dot and then this forward slash, we are going to go to our next path. what is our next path? It is data. Okay, data. And then what is in the data when we open it? This is the comma separated values we are talking of. Okay, so in our data, which is here, under that path, we have house prices .csv. Okay, so house prices .csv. So let's view this data. That is how it looks like, but those are very many rows. Just look at the top 5. Okay, look at the top 5 by writing, dot head, or you could look at the last 5 by writing df.tail. You see, so you could also use this to check how many entries you have. Okay, so it is always this plus 1, or you could just write length of df to check the entries you have. Okay, so you can see 1460. So how do we deal with this data frame? We need to access the values here. We need to work with these values. We need to do some analysis. Maybe we need to even train a model, something like that. So how do we do this? Okay, so there are very many ways of not dealing with this data. There are very many functions you can work out there with. Okay, so maybe if you want to just check on the columns, okay, just write df.columns. So you see we have ID, MS, a subclass. So you could be wondering what this data is. So I got this data from some cargo competition. House prediction. Yeah, it was this one. So cargo actually is also another, open data source that you could, check out. Just need to create an account, like I already have an account. Then when you go there, you go on a data set and you can search in any kind of data set that you want. Okay, and then when you open it, for example, let's take maybe an example of that. To always give you an opportunity of downloading that data, and then you can use it whenever you want or anyhow. Okay, Zero is free. Zero is free here, so you can get some time and go and check it out. So I got this data from a house price prediction competition. They had provided the data, and the task was to create a model that can accurately predict the price of house given some of these parameters, and so on and so on. So these were the columns, and we have the sale price. Okay, so that is how we check at the columns that we have in our data. So maybe if you want to check some of the values of the column, just have df, which is our data, you call it, and check maybe this column, what are the values, maybe what do they look like. You could also just have a df, also just write it like that. Depends on how, which one is easier for you to use. Okay, it is not like a must that you should always use something like that. Or you could also use a formula which is different from this. I see also most times people use it a lot. Right, use an iLog. Okay, df.ilog. So how iLog works is you always write the row, then maybe the column that you want to access. Okay. Okay, so this one is if you're to look at this is the row. Okay, this symbolizes the row. So we have the row, maybe we want the first row and the value which is in the first column. Okay, so if you check our index 0 has 60, and this, okay, it's here. So let us look at. So at index 0, which is what? Okay, let's just write it here so that we don't need to keep say. So what iLog basically means is now like this, we are saying we want at row 0, which is this, these are rows. So at row 0, we want what is at position 1, okay, of the column. So at position 1, we have at position 0, and then at position 1, which is this subclass, we have the value which is 60. So if you want to access maybe from a 60 up to maybe here, you can add it up to maybe 2. Okay, sorry, up to 3. Okay. So it counts from 60 and then it goes to the next column also and it picks. Okay. So maybe we want to also access from the first row. Okay, maybe up to the second one. You can also increase that like that. So the whole structure of iLog. Okay, you have your data frame and then iLog. Then you use this square bracket. So the first comma is for the row values, and then the last one is for the column value. Okay, so you could also use that to access your values. There's another one which is iLog. You've got oh sorry, that is, this one is called just log. So log usually gives you the potential or the ability to just use these column names as what? As strings. Okay, so it is always, it is similar to, iLog. You start with the row value and then the column. Okay, now for row values you can't use strings because they are numerical. Basing on the index, we use the index, they are numerical. It's only these columns that we can use what? We can use text, something like this. Okay, so you see, you can also access this just like that. And it's not a must. There's no rule or what that you should only use maybe this and this formula, or what. Just use the one that you feel that it is best for you. Okay, so let's look at some bit of some data wrangling and so on and so on. So most of the times data comes in format that we really don't prefer it in. Okay, maybe we want to change data types and so on and so on. Okay, maybe we want to pick only values that are in this range and so on and so on. So for illustration, allow me to use just a few columns here. Okay, can use here. So let's get our new data frame. Okay, this is also another way of when selecting columns. So let's say we are going to use can use only. Okay, let's use here salt. sell condition, then sell price. So we have to check how our data frame looks like. Okay. So we have that. Okay, yeah, sell condition, sell price. Okay, so maybe if you want to access, you want to check values in the data frame where, you know, maybe the sale was done in 2008. Okay, so we write a function, I may call it a function or some way of accessing, you know, our data. Okay, so maybe we want to access, okay, as we say, where our year sold 2008. Okay, oh, not DF, let's use, we're using DF, this is too much. So you see the year sold is only 2008. So check maybe 2007, only 2007, and so on and so on. Okay, so there are very many. Now this is where the booleans come in. You know, you're trying to equate. It queries the table using a boolean. Now it comes and checks through. When it reaches here, it sees, is this really equal to this? If it is false, it doesn't return it on the next table that is supposed to produce an output. But now if it is true, like this one here, it was true, it returns it as an output in the next one. Of course, now the index here, the index it writes here is the same index that it has this way. It doesn't again relabel the index. Okay. So the other thing is we could check the data type. Okay, maybe we want to see this. Is this really numerical? Okay. So how do we check the data type? Maybe we want to change it into some other form of data type. Okay. So new these types. Okay, this is an integer. So let's say maybe we want to change it into a float. Okay, usually price doesn't, you know, deal with floats, but let's just say that is how, you know, maybe we wanted to change our things. Okay, that's how we want that column to read. Okay, so use a formula like as type float. So we could give this column here, call it price in float. Our data frame table. Call that one. All right, something like that. Okay, so you see it has created this table. Okay, same with this. Okay, we just rename the same thing, but yeah, most of the times now when it creates, you know, it keeps on, it has already added it to that table. Okay, so maybe if you want it now, you just have to drop it. Okay, you could also check that out, how you drop some of those columns. So what I wanted to just, you know, bring most out in this video is now how you can read your values, I mean your tables, and then work with them. Now there are very many formulas out there that we can't exhaust all because we want to keep this video as short as possible. We're just trying to bring out some of these concepts onto you. So the most important thing that I wanted you people to check out on, and try to keep keep them at your fingertips, is using what they call map functions, map or apply. Okay. Now, most of the times you really want to deal with these columns, and you really want to convert them into something that you want, or you want to apply some mathematical function onto them. Okay. For example, maybe I have a function that multiplies some column. Okay, we have this column of ours, column n. So it is going to return a column times 2. So let's execute that. So we want to create a new column, our data frame. We're going to call it a math call. Okay. Maybe you're trying to create more features for you training your data, I mean for training your model, and you have few columns just like the ones we have here. Okay, so maybe you want to create something that the next column is going to be a multiple of this. So how do we really apply this using a map or apply function? We just get now our column, which is a sell price. Okay, then we put a dot map or apply. It depends on the one that you know most used to. It could be map or apply. They all bring the same answer. So just to explain this lambda function. Now lambda usually helps you express a function in brief. Okay, so just one thing you should master is that when I write dot map and I say lambda x, okay, now this x basically means when this function that I'm going to put here, okay, now for example, now if I'm going to now put mul, then we shall put in our x. Okay, that when this function is running through this table, I mean through this column that we've given it here, it is going to come here. The moment it is at this point, this value here is going to be our x at that moment, and this x here will run through our function mult, and it will produce this value. Then it will go to the next one, which is this. This is going to be our next x here. This x here will go be put inside here, and the output given, and so on. So on, it will run until it is done with the entire what? With the entire table or the entire data frame. So if we do that, we can check now our data frame. Okay. I don't know why my pandas today is being so stubborn. Talking of slicing. All right, so as you can see, just multiply this, I mean this by 2. Okay, you could use map, you could use apply. Same answer. Okay. 417, 417, it's the same answer. Okay, There are very many other things you could go and check out, like a group. Okay, maybe we say we want to group, you know, said you could always just press tab and then it will complete for you. So we want to group by years old. Okay, maybe we want to group our values by years old. Okay, and then we want to see the sum of prices. Okay, so maybe we're just interested in sales. We can just put this here, you know, and you could see the total in 2006. This is the amount that was got from sales to 7, like that, like that, like that. So group by is also something that comes in so handy in most of the times. Maybe if you want to see in totals, you want to see um, minimum, you know, minimum values. What was the minimum price in each year? You know, what was the maximum price in each year? Maybe you want to look at the mean. Now, usually you put in aggregation functions only here. What was the mean? Maybe what was the count? Count like you're counting how many were sold in that year. You see, something it comes in so much handy. So it is also something you should invest your time in. Otherwise, that is all that I had for you today. Let's meet in the next video. Thank you so much. See you.